Hi everyone, I'm Taylor Willis, and I'm going to be talking about the life cycle of a star. The importance of this topic is to discuss how stars form and its different phases that the star will go through, as well as how constant births and deaths of stars over very long periods of time create heavy elements necessary for the creation of other stars and even planets. Stars are born within clouds of dust that are scattered throughout most galaxies. A familiar example of a dust cloud is the Orion Nebula. Turbines deep within these clouds give rise to knots with sufficient mass that the gas and dust can begin to collapse under its own gravitational attraction. As the clouds collapse, the material at the center begins to heat up. This is known as a protostar. This is the hot core at the heart of the collapsing cloud that will one day become a star. As the cloud collapses, a dense hot core forms and begins gathering dust and gas. Not all of this material ends up as a part of a star. The remaining dust can become planets, asteroids, or comets, or even just remain dust. There's small stars, and there's also massive stars. So the first one I'm going to be talking about is the small stars. Small stars have a mass up to 1.5 times that of the Sun. Small stars are stars with about 1 solar mass. These stars are first born in a region of high density called the nebula. This region will begin to heat up and start glowing, forming protostars. If a protostar contains enough matter, the central temperature reaches 15 million degrees. At this temperature, nuclear reactions with the hydrogen fusions to form helium, and then that can start. The star will begin to release energy, stopping it from contracting even more, and it causes it to shine. This is now called a main sequence star. A star of 1 solar mass remains in main sequence for about 10 billion years until all the hydrogen has fused to form helium. The helium core now starts to contract further, and reactions begin to occur in a shell around the core. The core is then hot enough for the helium to fuse and form carbon. The outer layer begins to expand, cool, and shine less brightly. The expanding star is now called a red giant. The helium core runs out, and the outer layers drift away from the core as the gaseous shell. This gas that surrounds the core is called the planetary nebula. The remaining core, 80% of the original star, is now in its final stages. The core becomes a white dwarf, then the star eventually cools and dims. When it stops shining, the now dead star is called a black dwarf. Now the other stars I was talking about was massive stars. The life of this star is about 10 solar masses. Massive stars has a mass 3 times that of the Sun. Some are 50 times that of the Sun. First, the massive stars evolve in a similar way as small stars until it reaches the main sequence stage. The star shines steadily until the hydrogen that fuses to form helium. And then next, the massive star then becomes a red supergiant and starts off with helium core surrounded by a shell of cooling, expanding gas. Then the next million years, a series of nuclear reactions occur, forming different elements and shells around the iron core. Finally, the core collapses in less than a second, causing a supernova, in which a shock wave blows off outer layers of the star. The actual supernova shines brighter than the whole galaxy for a brief moment. Sometimes the core will survive this explosion. The surviving core is between 1.5 and 3 solar masses. It contracts to become a tiny, very dense neutron star. If the core is much greater than 3 solar masses, the core contracts to become a black hole. So a star's life cycle is very important and one of the most widely recognized astronomical objects. They represent the most important building blocks for galaxies. The age, distribution, and composition of the stars in a galaxy trace the history, dynamics, and the evolution of the galaxy. Stars are responsible for the manufacture and distribution of heavy elements such as carbon, nitrogen, and oxygen, and their characteristics are strongly tied to the characteristics of the planetary system. The stars in outer space have just always caught my attention, and I've always go out there every night whenever it's a clear night and I look at the sky. It's just something that I enjoy, and I'm really excited to do this presentation for this class, and I'm excited to listen to everybody else's and see what they have to say. I hope you guys have a nice day, and yeah, goodbye.